Hello, my name is Alden Beckett, and in this video I will be taking you on a tour of a procedural audio project that I set up using Pure Data, Kalimba, and Unity 3D. So first of all, I just want to go quickly into the scripts that we've modified to make everything work together here. First of all, we have within the game manager script, let's open that up real quick. Let me just close this down. First of all, we have our kind of initialization script here to make sure we are opening the right PD patch in the right directory. As you can see here, the patch name and the directory name, to make sure that we are in fact communicating with the right patch to make everything work together properly, as it is all based off one central patch. As we move down here, we start getting into the various bangs that we are sending from within Unity when various events happen to our PD patches. I'm going to go through them in the order that they appear in the script, but when we go into the PD level itself, it will kind of make a lot more sense as to why we've put these in its different positions, but I will explain it as we go here. So first of all, one of the things that I did do with my music patch was make it so that with every round that is added to the game from 1 to 2, 2 to 3, 3 to 4, etc., the music changes slightly in the way that it's presented. So this little bit of code here essentially means that when there's a game winner, as we see commented out here, then we want all of those parameters within the music to reset back to their initial settings upon going into the game. It's very, very important. Moving down here, we have a couple of bits of script that have merely been added so that as soon as the round starts and the tanks are reset, our various environmental sounds and our engine sounds are turned on. So here we have two of those things that need to start as soon as the level goes in and keep playing. This is a very important piece of script here. This is a very, very important bang to how my music works within the level. We have here music go. This is the message that's being sent. And essentially what this does is that, as I said before, every time a new round happens, it bangs that message, and that tells the PD patch that it needs to move on to the next increment of the parameters that are changing the way the music sounds. I think that might be the end for this patch. Let's just have a quick scroll through, or this script, sorry. Oh, there's one right down at the end here. So this essentially means, and I will try to remember to cover this when I go into the PD patch itself, that when there is a game winner, it sends this message, and this message actually not only bangs the sound file for when somebody wins, but it also stops the music being played that's ordinarily going throughout the game. So it does, there's two different functions that need to happen at the exact same time, which is why we have it here. So let's close that down. Our next one is, I believe, in the shell explosions. Let's open that up real quick. So in here, this is actually kind of redundant. We don't need to declare that twice necessarily, but it is in there and it's not damaging, so we've left it in. First of all, we have this one here. So in place of this part of the script that would ordinarily play a sound from within Unity, we have commented that out, and we have put in our own bang to send to the explode receiver within PD for our explosion sound of the shell as it hits the surface. That's the only one in that one there, because the rest is in the shooting one. So let's close those down, and let's go to tank movement. Very good. Open that up. So within here, we have a couple of things. So it starts getting very listy. So the first thing in this script is our get key scripts. So these are things that I needed to add into the scripts to make sure that when we are pressing specific buttons for movement for either tank, we have W and S for forward and back, or acceleration and deceleration and reverse. for player 1 and then the same for player 2. We are making sure that when those are being pressed and held down, that we are banging the engine up message to make sure that our engine has ramped up to its maximum value. And then we have a similar thing for the side movement, for the axis movement, A and D left and right. And again, for left arrow and right arrow for player 2, we want to make sure that when the tanks are turning in either direction, we are banging this message to the PD patch, which is turning on the amplification for our turning sound. And the same thing, obviously, in reverse for turning it off. When the key is lifted for either player, we are making sure that we mute the amplification for that as well. And we'll go into kind of making sure that this behavior is very smooth when we get to the PD side of things. The next thing that we have here, I believe, this was an interesting interaction that I had to resolve. I had to comment out very specific parts of the script and leave others in, so that when no input was being put in, funnily enough, that we were constantly banging the down message. So the volume of the tanks was always staying down. The speed was always on down unless an input was being pressed, and that kind of helped to resolve a couple of behavioral issues I was having with the PD patch. I believe that's all for movement. Yeah, so let's close that down. The last script that we've modified here then is the tank shooting script. Let's have a quick look here. Okay. So the first one that we run into in this script is our weapon charge sound. So this means that whether it's space for player 1 or enter for player 2, whenever the player is charging up a shot, we are sending very quick bangs, and it's doing it per frame as the private void update part of the script. It's banging the weapon charge receiver within PD, which is going to give us a repeating tone. And then when the button is lifted, then we want it to make sure that it is going to play the remainder of that sound, which is kind of an interesting thing I've set in within PD to make it like a randomized thing we'll go into in a bit. The last thing we have here is this last part, which is our weapon shot bang. Basically what this does is that this is for when the shell actually leaves the chamber, if you want to put it that way, of the tank. We want a specific sound to play at that moment as well. So that's why we have this bang here. So that's it for the script. Let's close that down. Let's move on to the second screen here and start examining the PD patch. Let's do that. Just make sure that that is switched over. Yeah, cool. So this is the presentation for the master layer of the PD patch. First of all, we have up in the top left, we have our net receive dock or port. And we have, this is the last banged message being displayed here, so we can actually monitor in real time when something is actually happening. We have our master catch. So anything that is, as you can see here, everything's being thrown to master and then caught here, which is then going into the DAC. So this is nice and out of the way, and we don't have a really complicated spider web trying to organize so we can see what we're doing. So that's all nice and organized there. We also have a stop all button. Obviously, at this point, we're not playing any sound, so it's not going to do anything. But if I hit that, you can see that we're banging a message on every relevant sound to make sure that it stops playing, so that when we're going in and out of the editor, we have control over that very, very quickly. So let's start going into the patches then. First of all, you can see in our music web, I'll call it, here, we have, first of all, a music go. Now, we saw this in the script. This was for every time that a round was added in the game. We wanted this to be triggered, and that, first of all, starts the hats, starts the kick, starts the music, and every subsequent bang, once the music is already playing, will reset the beat, reset the kick to the first beat, and it'll also start our next incrementation of the tremolo effect on our guitars and bass and things like that. So I can just demonstrate that to you very, very quickly here. And then if we hit it again, everything starts again. It's all still synced up. And we can stop that with the stop wall at the top, or we can use this button here. And we can also reset all of the values since we're not in the game and it's not doing that for us automatically. So we're making sure that we've hit that to reset. As you can see here, I have left on this surface level our amplification settings here. This was because in lieu of having any kind of mix sliders or anything like that, I can mix, just changing the values here, everything kind of on the same page. I can change these values as I deem fit to get a nice balance of everything together without having to go in and out of different patch layers. So I reckon the first point to jump in then is maybe with the main music patch, which has got our guitars and bass and things like that. So this is just for reference up here. This was the BPM of the sample that I had recorded, the guitar sample here, so that we can use that, do some maths and figure out the MS values that we need to use for other elements in the music. So first of all then, we have our guitar riff. Now here is very, very simple. We are opening a sound file in the directory, the bass directory for PD, and we are reading it, and then we are looping it so that every time the file stops playing, we are banging again, and we're going around in a constant loop. We have our receive stop. This is just all linked up to the various stop receivers, all over the place are being sent to here or receiving information from here so that we can stop everything. That's a very kind of simple loop we have going on here. We have, every time that there is a new round, we also play a one-off whistle sound here. I can actually just hit that for you now, I believe. It's a nice little cowboy touch to the level. And that only plays once because we just want it to happen when each round starts. We don't want it to loop like the guitar does. I suppose the next thing to go into that is most relevant is then our tremolo over on the far right. So this is a really cool little thing that I had to kind of figure out the logic through kind of a little bit of experimentation and well, logic. First of all, we have our inlet, which is for things on the other level here. We want to have it so that I believe the music reset comes in here, as you can see on the left, and it comes into here and it resets this to where I want it to be. Now, there's a little bit of experimentation with trying to make sure I had the right value to make this behave in the right way, so that when round 5 or whatever came around, the final round, it would actually go to the place within this selector that I wanted it to. So a little bit of experimenting there. So first of all, we have a message box sending a value of 0, and then going from there into a float, we have a thing that every time it's banged, it is adding 1 to a selection of 6 different values, which we have down here, so that every time we bang this, if I just play the guitar sound, we'll hear it as well. So right now we're at 0. You can see this down here. Every time we bang this, selecting a different value from these different message boxes, which is speeding up the tremolo. As you can see there. Let's stop that. And then we will reset over here. Boom. Lovely. We've gone back to 0. So these values are going into, this is just to check we're on the right one. It's going into an oscillation. Now, we have a clip here to limit the potential values. So we have -1, and 1. That's going to be our minimum and maximum values for the oscillation. And then modifying the output of that, we have our depth control for the tremolo effect. Now we have some very complicated maths here, in that we have whatever value is here, the float 1, we are taking that away from 1. and that is giving us a second value here. And this is what gives us our nice oscillation curve, these two values put together. And then those are being sent to the outputs of the different instruments in this patch to create that nice tremolo effect. Let's then go into some of the very complicated bass and guitar instrument patches that I've repurposed for this. First of all, let's try, actually, since we're here on this page, we'll go into the sequencer first. So this is a sequencer that I built for this purpose because the patch did not come with one. We, first of all, have our Metro 7500. Okay, this is our kind of our standard beat time, beat length, and within that we have, let's actually just play this real quick if we can. So if I okay, and then I'll stop the bass as well. So this is our sound right now. And what's actually happening is that we have these notes being used as these are the MIDI value of the notes, and this is the MS value for when we want each note to be played. So this is actually forming like a step sequencer of exactly how long I wanted it to be between each note going into an outlet here, which is then feeding, as you can see, we can see the MIDI notes being changed, and that's going into our actual guitar patch. So you can see various behavioral objects going into other dependencies, which form the kind of acoustic properties of the sound. And it may not be perfect, but the behavior is right. And that is very important to make it sound relatively convincing. Some very difficult maths. You have audio inlet values being used in mathematical equations, various filters, as I said before, envelopes, MIDI to frequencies being used, making sure that those are all coming out as audio. And we have some limited control on this level of the patch in how that actually sounds. So here we have our bass value of 5 being shot into here. From 1 to 5, this is kind of which pickup is being simulated on the guitar. And this modifies the bass response of that sound. But we like it with a little bit of bass in the low end, so we're keeping it down there, and we're making sure that this can be changed however we need. So let's bring that back down to 5. We then have, for behaviors, whenever we're setting go, whenever we're telling the music to play, we are banging a 0.1 value. We're making sure that happens when the patch is loaded up with a load bang. So we have our volume on 0.1, and we also have our receive for stop being done here, so that we are controlling, when we're pressing stop, go, we are cutting off the amplification. Another really important thing to notice in this control here is that we have to put a receive stop going into the sequencer. Now that will stop the sequencer when it's finished its loop, but that's not ideal. So that's why we also have these which cut off the amplification. So otherwise we still have the things going. I can demonstrate that here. If I press stop, but turn the volume back on, you can hear that that's still ringing out. And we don't want that. We want it to stop when we press stop. So we have that amplification being cut off. We have a very similar patch here with the bass. Probably not worth going into that one as well. But we have another sequencer that is being used at a lower octave CC notes. Again, you can see our step sequencer delay timers being sent from the Metro Bang. And we can see that this has a multitude of various mathematical equations being modified by certain values within some of these patches. As you can see here, a fantastic patch that was created with this car plug dependency, which gives us all sorts of very interesting functions. We're not actually using this part because we are not using MIDI notes. per se, but or any MIDI input necessarily, but we are using MIDI note values, so we're still having that into the sequencer here. We then have our load bang values for making sure that we have the sound that we want in there when we load up the level. Again, we have that on a loop here, making sure that we are getting this constant repeating pattern, and we're making sure that we are able to stop that when necessary. You have our on amplification value, we have our off amplification value. So let's go out of this part of the patch here, and let's go into the hats. So using a similar kind of basic way of doing the step sequencing, we have our master bang for the hats. We have our on and we have our off, and then we've set up a delay so that instead of just getting one bang every time we're sending that message, we're also getting a second and a third one, which we'll go into here, as you'll see. That is going to give us a nice kind of galloping rhythm. So let's play that real quick. I think we have to play everything together. Let's find out. Oh, we don't. Okay. So as you can see, we're banging once from here, and then we're having delayed ones from here to create that nice gallop, that nice rhythm. That's obviously going into our PD patch, which again results in a lot of math. Fantastic patch that's been repurposed for this. I really, really loved the sound of it. I've modified a couple of values to the various band passes and the actual frequencies being filtered, but for the most part, this was just such a great patch that all I can really do is try to understand and deconstruct. We have a lot of phasers, a lot of sawtooth waves being sent out. We have noise. These are all being modified by envelopes, by high passes, band passes, low passes, to get the desired effect, modifying each other a lot. So let's stop that. Let's go then down to our beat kick. Similar thing again here. Except that the behavior of this patch is sort of unique. We have a little bit of humanization going on in the behavior that's been added to it. If we go into here and we play it on its own, so you can hear that we are getting a little bit of random modification on some of this, using the various formants and the envelopes going into some of these various parts of the patch, that we're getting a very nice sort of natural modulation on this kick drum sound. And actually sounds surprisingly natural. Again, behavior being more important than quality. This is just a calculator that I'd use down here, redundant as stated there, for calculating the appropriate MS values for the BPM. So let's stop that. Okay, so let's close that down. Let's go then into, again, we've already seen this, but this is just a simple read sound file. So that when we hit that, we have our game winner sound. So let's move on then to a wind generator. So obviously we have this starting when the game level starts. Fairly obvious reasons. We want this to be playing the entire time. And within that, we have a fairly complicated patch. Now, this mostly consists of noise being sent and received by various, I guess I'd call these columns, which are modifying the sound in different ways, and they are receiving different amounts of modulation from this sub patch here. Because of the different values that come after, they are changing and shifting constantly. They have different characteristics. They are being panned, and they're being thrown in a similar way to we have on our master patch out to these left and right outlets, left and right amplifications into an outlet. We have control over lots of different characteristics, which have been fantastically made from this very basic noise wave and shifted, modulated, oscillated to create a realistic sounding wind sound. Moving then into the tank behaviors, we have, I can just play that for you quickly actually. So we've balanced these to taste, taking away some of the characteristics that were either going to clash frequency-wise with the rest of the mix when we play the level, and emphasizing certain things that we really wanted to cut through, just modifying some of these parameters with the frequencies being changed and the volumes of each individual characteristic within the patch. We can stop that. We have, first of all, a fantastic patch that I've kind of stitched together from two different Andy Farnell specials, as we'll refer to them. We have a really great turbine. I think this was originally for a jet, but for the purposes of this level, seems to work just fine. We have that, these two sub patches here, various of noise and oscillators being put out through band passes, different values for time, things being randomized to a reasonable degree, or certain unpredictable behaviors being added in here, being sent through here into a low pass. And then we have our speed control here. This, as we see here, if I turn the engines on, and I start pressing these buttons here, which are simply these two inlets, message boxes being banged, we can see because of the various envelopes within this patch, we're not suddenly jumping up and down. We're actually sliding up and sliding down. Despite the value change being sudden, we still have the desired behavior, because the tanks in the level don't really have a lot of control over speed. You're either going very slow and then very fast, or you're stopping and slowing down. You don't get to just crawl. So that kind of control isn't necessary for this implementation. We just need an on and an off, and then a behavioral ramp that sounds realistic and isn't too jarring. So that's our up and down now. We also constantly have this behavior going on in the background. This is the tugboat patch from Andy Farnell, and this I felt really added a level of randomness and unpredictability to a patch that was going to feel very kind of stale when the tanks weren't moving. It would just be like this constant, well, you can hear it, this constant low vacuuming sound, and adding this these clicks, these pops, these things that would be kind of like a bit more characteristic of, you know, a toy tank. The turbines moving, the tracks moving on the tanks. I've really felt it kind of added an extra layer. So we've got those two kind of working together and coming out of the outlet here, all contained within one area that we can turn on and off when we need to. PD Explode, another Andy Farnell special. We have here an array of various different scalable values. It's really important for the adaptability of a patch and for the scalability. If we go into the blast control, this for me was one of the things that stuck out to me as one of the most important parts of the behavior of this patch. We have randomization. So this actually means that every time we are sending a bang to play this part of the patch, they were getting a degree of randomization in the delay of some of the parts of the sound being sent out, and thus a randomization in the way the explosion sounds. That can vary in kind of like the size and the shape of the explosion when the shell hits something and detonates. So we have, again, lots of catching and throwing to send us out of this outlet here, and then going into the various amplifications in our layer here. So we can play that. randomization, giving us a nice bit of change every time a shell goes out. Again, not only important for kind of not becoming irritating to the player, but also because we had to take into account the fact that there are two tanks. If they both fire at once, we don't want those explosions to have phase issues because they are the same sound. We don't want them to build up on top of each other and simply amplify each other. We want to make sure that there's a very, very high probability of the sounds being different enough that we're not getting issues within the kind of audio engine with that. So our weapon charge we have here. Let's open that up. So within this, we have a very kind of simple, would ordinarily be sort of like an alarm-like sound. I wanted to have something that would play when it was kind of like an alert for when one of the two players was firing a shot, so that when they're holding down the space bar, it's constantly pinging kind of like this first note of the sequence, and then when they release, you get this nice randomization happening every time shot is actually fired. Just a nice little touch, a little bit of intricacy. We have obviously, you know, these various things being modified, their values being modified, the pitch being changed every time we do that. So really, really nice. Let's close that down then. Let's bring up weapon shot. So this is kind of a surgically modified version of another patch. We wanted to have a sound play every time a shot left the chamber, and not just the previous one that you heard before, this kind of alarm sound, but a more natural sound that was more in line with the behavior of an actual tank. So what I've done is removed redundant parts of that patch, first of all. But then I have actually, just find it, use me. Oh, it's not in this one. Here it is. Okay. So you have a various triggers, bangs, sequences being shot off, receiving information from the different patches, the different send and receives from within them. But then down here, we have a number that is being randomized. Now this number here, these numbers working together, determine the pitch of the sound. So sticking this into the right inlet on that allows me to, whenever this is hit, whenever we're getting the receive shoot message in here, we have a base value of 100, which is the same as here. It's important that this is similar. And then on top of that, we're adding a value between 1 and 20. So we get that nice randomized pitch, which sounds really silly when you click it a lot like this, but within the context of the game, makes things sound a lot more natural, which is really, really cool. Let's close that down. Next we have our weapon. Nope, we have our turn sound. Okay, so you can immediately see here that even without turning on the engine, turning on the turning sound, we are randomizing values. So this is a nice kind of like matrix that I set up here. This is, for the most part, noise. This is our noise generator here. This is our envelope on the right side. A kind of maybe slightly unusual, but still practical envelope that we've set up to go from a 0 to 1, 0 to 0.1, sorry. So that's our volume slider going up and down. And here we have, first of all, a metro. This is pinging every second, or 100 millisecond, or 1000 milliseconds, sorry. We have a random value being changed. So we have our base 1000, and again here. Then from that, we're adding a random 1 to 1000. This means that it could be anywhere between 1 second and 2 seconds that this value is being banged, this value 1. We have kind of this looping thing where it's constantly going around on itself, similar to that we had with the guitar sample. Then we have a second version of that on the right, basically identical. that we are again pinging at a random time. So these are constantly going 1, 3, 1, 3 at randomly determined times. So this is meant to kind of replicate the sound of shifting sand. So let's turn it on. You can see every time this is banged, it starts to move down. Sometimes they move very quickly, and that's fine. It's fine if it stays up for a certain amount of time and then waits to go down, as long as there's some amount of movement in the filtering that is happening with this sound. And we'll hear that in the level. I thought this worked really well. So let's close that all down and let's play the game. So stop all. Let's go back to our main screen and I'll just check that that has happened. Yeah. Cool beans. And let's play the game. So you can hear that sand shifting. No matter how much we hold that down, it's never going to play the same modulated frequency shifting. And that envelope's really cleaning that up and making sure it sounds natural. Over engine. Not too loud, but audible enough. And we have our shooting sound. There's various patches working together. And you can hear immediately there, we have that escalation from the tremolo. Now, if I keep just incrementing the rounds, you'll hear that the tremolo will keep going up and up and up until a player wins, it cuts everything out, and then we restart back at the first increment. All of these sounds obviously work also on player 2. So let's just go to the next round. Our victory screen, and now everything is reset back to the first increment. We're all back to the beginning of the game, and we've kind of de-escalated everything back down to where it should be, as if you were launching the game for the first time. So let's press our stop all button, bring out of the game, and that's it for my level.